In this question, it is given that figure shows a venturi meter through which water is flowing. The speed of water at C is 2.5 centimeter per second. Speed of water at D is. So let's say the velocity of water at point C is given as nothing but 2.5 centimeter per second, and speed of water at D, Rm is to find out. Let's say that is equal to nothing but V, or I'm just taking it as nothing but V2. So this we can take it as nothing but V1. And consider that pressure over here is equal to P1 and pressure at this point is equal to P2. Now we are going to apply Bernoulli's theorem between these 2 points. So we can write pressure at point 1 plus half into rho into V1 square plus rho into G into H1 should be equal to pressure at point 2 plus half into rho into V2 square plus rho into G into H2. Now for the measurement of gravitational potential energy, assume that I'm just taking this line as the reference line, so that with respect to reference line, the gravitational potential energy at point 1 and point 2 is equal to 0. Now just consider that pressure at point 1 is taken as P1, and that is equal to, or we can write pressure at point 2 as P2, and we can just write on the left side. So it is P1 minus P2 is a difference in pressure between these 2 points, is equal to, we can write as half into rho into V2 square minus V1 square. Now the difference in pressure we can find out by using this difference in height, because pressure is equal to H into rho into G. So this is going to give the value of difference in pressure. So pressure we can use that equation, H into rho into G is equal to half into rho into V2 square minus V1 square. So we can write this rho and this rho get cancelled. So we can write 2 into G into H is equal to nothing but V2 square, which is Rm is to find out the value of V2, minus V1 square. So we can write 2 into G into H plus V1 square will be the value of V2 or V2 square, or you can write V2 will be equal to under root of this value. So we can write this as 2 into H is given as nothing but 5.1 millimeter. So we can write this as 5.1 into 10 raised to minus 3 meter. G we can take it as 10 plus the value of V1 in question. The value of V1 is given as nothing but 2.5 centimeter per second. So we can write 2.5 into 10 raised to minus 2 meter per second, the whole square. So this is going to give the value of V2 square, or you can write this V2 square is equal to 102 into 10 raised to minus 3 plus 6.25 into 10 raised to minus 4 is equal to V2 square. We can just rearrange this one in terms of 10 raised to minus 4. So 1020 into 10 raised to minus 4 plus 6.25 into 10 raised to minus 4 will give the value of V2 square. So if you are adding these things, we are going to get something but 1026.25 into 10 raised to minus 4 will be the value of V2 square, or you can write V2 will be equal to under root of this. That is equal to 32.03 into 10 raised to minus 2. Or we can write approximately equal to 32 into 10 raised to minus 2 meter per second, or you can write which is equal to nothing but 32 centimeter per second.